This is CM3900 Vector 1 exercise 5. We're given f is x plus 2y plus z squared and a y squared I minus xz j plus zk. And if you look in the notes, the relevant equations that we need for what we're asked for are 1.2, 1.6 and 1.7 to find del f, del dot a and del cross a. So first of all, del f is partial df by dx I plus partial df by dy j plus partial df by zk. Well, partial df by dx, there's only one part with an x, and derivative of x with respect to x is 1, so the first component is just I. Then we have partial df by dy. Well, partial derivative of f with respect to y is just going to be 2, so we have plus 2j, and partial derivative with respect to z, well, the only part that contains z is the end there, z squared. Derivative of that with respect to z is 2z, so 2z for the k component. Next we're asked for del dot a. Well, dot product is just a sum of pairs of components multiplied together. So generally speaking that is, but if it's just del dot a, then it's the partial derivative of the x component of a with respect to x plus the other two partial derivatives with respect to components. So the x component is the same as the I component, the y component is the same as the j component, the z component is the same as the k component. So ax in our case is equal to y squared. Derivative of y squared with respect to x is 0. Ay in our case is minus xz. Derivative of that, partial derivative of that with respect to y is 0 because there's no y in there, so it's treated as a constant. And partial d by dz of the z component, well, partial derivative of z with respect to z is 1. Therefore, del dot a is simply 1. To work out del cross a, we need to construct this determinant. Or there's an explicit definition of this in the notes, but it's also useful to look at how you can do this otherwise. So we label three columns I, j, k, and set out the del term, partial d by dx, partial d by dy, partial d by dz, del operator I should say. Underneath that, the three components of ax component, ay and az, which are y squared minus xz and z, as we've already seen. And then to work out the cross product, to get the I component, we cover up the I column first of all, and then do the diagonal product, partial d by dy times z minus partial d by dz times whatever's in here. In this case it's minus xz. So we put that down here on the right, and that's our I component. The j component, we cover up the j column, and this time we go for the other diagonal, we go partial d by dz of y squared minus partial d by dx of z. That gives us our j component. For the k component, we're back to the other diagonal, we cover up the k column, and we get partial d by dx of minus xz minus partial d by dy of y squared. And if we work out those partial derivatives, well, partial derivative with respect to y of z is 0 because y's are a variable. Anything that doesn't have a y in it is a constant. Derivative of a constant is 0. Partial d by dz of z times a constant minus x just leaves the constant, so it leaves us with minus x, but we've got a minus sign in front, so it becomes plus x. So we have x as our I component. For the j component, partial d by dz, the y squared is 0, partial d by dx of z is 0 because these are both just constants, derivative of constant 0. And for the k component, partial d by dx of minus xz is just the constant that's multiplying x. So so it's minus z in this case, and then partial d with dy, y squared is 2y, so we end up with minus z minus 2y as our k component. And then we need a dot del f. Well, as I suggested earlier, in general the dot product is just the sum of pairs of components multiplied together. So we've got a and del f here, one above the other. So we're just multiplying pairs of components. Here we've got 1i times y squared, 1 times y squared, we put the y squared down. Then we have 2 times minus xz, so that's going to be minus 2xz. Then we have 2z times z, so plus 2z squared. And then lastly we have del f cross a, so we form our determinant again, I, j, k, headings for columns. Del f components at the top, which are 1, 2 and 2z, and then underneath the a components, the ax, ay, az, that's y squared minus xz and z, and do the same as before, cover up the I column, and 2 times z minus xz times 2z is our I component. Cover up the j column and take the other diagonal, y squared times 2z minus z times 1, that's our j component. And then lastly cover up the k column and work out the other product, 1 times minus xz minus 2 times y squared.